Okay, if we can start with the pressure currently on data center networks. I mean, the whole digital world is exploding, so there's that. And then somebody decided that AI was going to, come along and make things even more complicated, shall we say. So just, I guess, your thoughts as to, what what networks are being expected to do at the current time.
Yeah, you're dead right to mention AI. Probably is the most critical factor challenging the demands on networks. And networks are obviously somewhat under pressure anyway with the growing amount of data traffic, but AI will be an exponential change in that for sure. The growth predictions vary from fairly steep to very steep. Um, but in reality, what does it mean? I mean, essentially, we're deploying a huge number of data centers. Those are the largely large data centers at the moment, as you know, either for training or for inference or whatever. GPU as a service is really one of the key driving factors in this. So companies like CoreWeave, who we're working with, are deploying GPU now globally to essentially underpin this AI revolution. And that means that with all of this demands for additional data centers, GPU compute going into data centers, the only way that that's ever going to get to the end user is with a quality high capacity network, which essentially is where Nokia comes into this. And we've seen, as you know, massive announcements about huge investments in data centers from the hyperscalers, but also a number of others. There's a big growing market, not only in large data centers, but an emerging market in edge data centers as well. So AI drives also the need to have inference compute capability closer to the end user for latency reasons and for various applications. So I think that will see the drive also for edge data centers. And again, those are going to be probably in places where there's a limited network connectivity today. So all of that is going to require this high capacity, low latency network to link all of that together. And that's really going to drive huge demands, I think, on network capacities in the future.
Okay, and in terms of what Nokia's up, clearly you're up to many things, but one of the things I know you've done fairly recently, you've introduced the Nokia event-driven automation, and we just
Yeah.
good to understand where that fits within the sort of landscape you've just described as to what's the thinking behind it, and I guess most importantly, what are the benefits it brings?
Yeah. Okay. So basically, we're starting with this with the philosophy of reliability. So there are a couple of things around here. So when you're talking about data center fabric, data center architecture, a lot of that today is somewhat still manual. There is some level of automation built into that, but the missing piece of the puzzle essentially has been this event-driven or automation. And the way that we're looking at this is to make this sort of environment a successful, manageable, low error environment. In fact, our philosophy here is to drive human error to zero. That's what we want to do. Because again, if you're going to automate something, if it works well, great. But if it doesn't work well, you're automating something and then driving huge scale into something that's going to create more and more issues. So EDA and our SR Linux data center fabric solution, the whole concept behind this is essentially to give customers the ability to know they've got a quality product, that it essentially is designed around the right type of architecture, but then allows them to automate that and then do that and drive those requirements at scale. And just as a way that a philosophy that we approach here. So there's a typical metric in the industry that you might have one developer, or sorry, three developers and then one tester. The way that Nokia does this, we have one developer and one tester. So we really focus on getting that quality day one. That allows you to then have a quality product. Then when you start driving that automation of those services in your network, you know that they're reliable, they're going to work. So essentially what EDA is the automation element of that framework. And that's essentially what we've launched with EDA.
Okay, and another thing I noticed very recently, I can't remember if it was this week or last, but you announced your involvement in a trial. So I talked about the reliability angle, but clearly the need for speed is always there. And I think there's a trial, is it 800 gigabit Ethernet, Chicago to London? I think it's yourselves and some other folks. Again, perhaps you can just talk us through the importance of that trial and from where the trial goes in terms of what people when people might see it in shall we call it a production environment.
Yeah, I guess the one that you're referring to is the trial that we've just completed with Colt,
Right.
and I believe also is it Windstream? I forget the name of the other company that we're working with in the US because I haven't checked it out. I have to say in the last couple of days. But yeah, in essence, that's long haul optical transport. And again, with the evolution of AI and with the growth in traffic demands that we're expecting, higher capacity over longer distances is clearly going to be the order of the day. And so, yes, that trial that we've just completed with Colt, etc., has been very successful, and hopefully then helps to underpin their network and other networks that will need this kind of capability as we move forward in this ever evolving AI era.
And clearly, while you're trying to do the best you can for data centers, there are some bad actors out there that are trying to stop you doing things, shall we say? And I believe that I think a recent report of yours suggests that the telecom infrastructure industry yourselves are facing increasing levels of sort of cyber attacks. So just be good to understand, how bad that's getting, and just, is it a, who's winning, I suppose, if that makes sense.
Yeah, it's a bit of an arms race, isn't it? That type of thing. Well, I mean, the one that everybody knows about, of course, is DDoS, denial of service attacks. And we are seeing increasing volumes of those attacks. And of course, AI will unfortunately give the capability to bad actors to only go and further automate that and drive those attacks at scale. So that's a negative element of that in that sense. But there are products and there are solutions out there to help mitigate that. And we have our own platform called Deepfield. And Deepfield essentially is not only analyzes and identifies the threats, but mitigates those threats as well. So a Deepfield Defender product. In fact, we've been doing some trials recently with different customers, and the number of attacks is growing significantly. And actually, when we implement these products into our customers' networks, even a trial sense, they're absolutely amazed how many attacks they're seeing and where those attacks are coming from. I obviously can't go into details, particularly on some of the situations we've seen with certain customers. But that is one aspect, the DDoS aspect. But coming down the road quite quickly is the quantum, and quantum computing, whilst it offers huge benefits potentially for humanity generally, it, as ever with these things, there's a positive and a negative. And the negative element of this compute power means that when a quantum computer is available, and we talk about that being Q-Day, and I think IBM is one of the leaders in the development of quantum computing technology, and they say they'll have a fully operational system by, I believe, 2033, for example. And the dates vary on when people will have this capability. But when you do have that capability, the current security capability of networks will be essentially compromised, because it will be able to hack at quantum speed. And that means unpicking the security elements of the network within minutes, which would take current computer technology thousands of years. So that's the scary part. And that's why we're actively encouraging our customers today to deploy quantum safe networks today. And we have that capability built into our IP and our optical portfolio. So we call that a defense in depth strategy. And essentially what that does is it prevents somebody from harvesting the data from the network today to decrypt later when they have that quantum compute capability. Because that's the key concern right now. If they can take the data, they store it, when the quantum computer is available, then they can hack it, and then they can access. And the reality and the threat for everybody is that at a business level, that's all of potentially your industrial secrets, but all for every human, that's your bank account details and everything else. So this is why networks need to be quantum secure and quantum safe now.
Okay, and in terms of getting that message out there, because I mean, many people are aware of quantum computing, but as you say, they're thinking, well, it's not till the 2030s when these things are going to be available, and perhaps therefore think, we've got a bit of time. But what you're saying here is actually no, because the bad actors know, that if they can obtain information now in a relatively light security, if you like, from the quantum perspective, then they can store it and then use it at a later date. So do you think that enough people are aware of just how bad this threat is? Bear in mind, as I say, everyone thinks quantum computing is not going to happen for quite a while, but
yeah, I think the message is getting out there. We obviously have customers that are deploying quantum safe capability into their networks today. In fact, we consider that, and I think that the customers are starting to consider that as table stakes. So we actively encourage all of our customers and anybody building networks to build in that quantum security today for those reasons. So is there some work to do? Probably. But us and the rest of the industry are working with the community to make sure that that's understood, and we're working on that.
Okay, and perhaps if we can just return to AI for a minute. I
Sure.
think Nokia fairly recently joined the AI Pact, so it'd just be good to understand, um, if you can, a little bit about what that is and why Nokia thinks it's a good thing to be involved with.
That's a good question. I'm not too close to that, actually. I haven't followed that specifically. So I'm not aware of what our involvement is in the AI Pact. But AI, again, is a fundamental life changing, industry changing, everything changing technology. That, together with quantum computing, is going to change the dynamic and the paradigm of networking and, frankly, everything for everybody, I think, in the next 5 to 15 to 20 years. So AI is a fundamental technology. It's fundamentally linked to communications technology. So we will have joined that for exactly those reasons, because we clearly need to make sure everybody understands the impact of AI, but also what the impact of AI is on networking. That's going to drive, as we've said, a huge increase in demand for networking capacity, locations, and areas for that networking to be deployed. And in essence, that's why, again, the only way that AI actually means anything to anybody is that means for me, and let's say me and you at home in front of our computer using AI for any purpose, that's going to require a network that allows us to get that service, not only in the most effective, high quality way, but in a low latency way, for example. And also a secure way, as we've just covered. So that will be the reasons that we're part of that pact, because we see networks as the underpinning capability to bring AI to everybody in everyday life.
And I guess the good news with AI is obviously there's the challenge there you've outlined, but yourselves and other folks in the industry, you've got the ability to harness AI to help with your solution. So are you already doing things or other plans in the pipeline? How are you using AI to improve, add value to what you're currently able to provide customers?
Yeah, absolutely. So, I mean, we're starting to build. In fact, we have built AI into some of our technology. So we talked about EDA earlier, and we talked about our SR Linux data center fabric solution. So, the way that we've built AI into that is actually to start to use simple language within the operational capability of those solutions. So instead of you being a highly trained operations guy in a knock center, for example, and having to program and use certain language and certain code, you can simply say, tell me how my network's performing, provision this circuit, connect me to from A to B or to C. And so you can use simple language to essentially start to provide commands into the network, into the system, which means you don't need to use complex technology or complex language or complex algorithms or programming language. You can use simple language. So that's one way that it makes it more accessible, but it also means that that it's much easier for customers to be able to maintain that with their operations staff. And there are other ways that we're starting to build AI into our capability today, but that's, I think, one really useful, clear example.
And maybe just as we finish, in terms of connectivity, I mean, I started in IT in the storage industry, and that was a bottleneck for a while, and then it goes somewhere else. Just your thoughts, I suppose, as to where connectivity fits in to the overall sort of IT infrastructure landscape, how critical it is compared to some of the other components, and where you think bottlenecks. Do you think connectivity might be a bottleneck sometime in the future, or do you think the rate of progress is such that it will be somewhere else, if at all, or everyone will be in perfect synchronicity, if that's possible?
Yeah, I think when it comes to that, I mean, it's a bit like the balance, isn't it? The demand, and everybody builds capacity into the network to cope with the demand. The little bit of the unknown quantity, as I said earlier, is how steep this curve of growth is with AI traffic. Because essentially we've seen at the moment is the deployment of the infrastructure to underpin AI, as I said, GPU capability being deployed globally. But really the applications that run on that GPU, be it in the enterprise or be it in the home, those are the things that are going to drive the traffic. And then coming to the point about the traffic, in essence, we kind of view these days that all networks are mission critical. We used to talk about networks being mission critical for life and death situations like signaling on a railway. Absolutely it is. But really, these days, a gamer at home, a 12-year-old, I have a 12-year-old playing at home with his gaming, he considers the network mission critical, because if it goes down or the latency isn't what it wants it to be, he's disadvantaged against his fellow players in games. So in reality, mission critical now is more a perception thing rather than a real thing in that sense. So we think of the networks being mission critical, and therefore all networks and the delivery of the service, be it into the enterprise or be it into the home, are going to need to make sure that they provide the services that people expect. And the only way to do that is to make sure that your network is robust, is high capacity, is low latency. And that's essentially where Nokia, we feel, comes into this, not only into the current communications landscape, but into the future landscape driven by AI.
Okay, it's been great to chat and some great insights into what's going on in the networking side of what's a very dynamic digital industry at the moment. So, Paul, really appreciate your time. Thanks very much.
Very welcome. Good to meet you.